Okay, so I'm going to go through another partial fraction decomposition example with you. This one doesn't have any quadratic factors though, so we might want to do another problem in a bit with quadratic factors. So what was the first step? Do you remember? Factor the denominator first, right? Okay, so 2x plus 3 is the numerator, and then let's go ahead and factor the denominator into as small pieces as possible. So let's see, we can take out an x squared. What does that leave inside? X squared minus 9. Then can we factor the x squared minus 9? Yeah, into what? X minus 3, x plus 3. So notice how we don't really have any quadratic factors. I guess you can consider that x squared is a quadratic factor, but it's really, we're just going to call it a linear repeated factor. Okay? Quadratic would be if it's, you know, a big thing you can't factor. Okay, so this is actually going to be broken into 4 fractions. We're going to have a over x and b over x squared, because that's a repeated linear factor. Then what? C over x minus 3 and d over x plus 3. Okay, good. There's our setup. Now how do we do the next step? What's the next step? Not yet. Multiply by the least common denominator. So the least common denominator is x squared times x minus 3x plus 3. So that cancels that entire thing, of course. And does it leave anything else left over to multiply here? Nope. Okay, so it's going to cancel out that, but what else needs multiplied on the top? X and x minus 3, x plus 3. Can I just write it as x squared minus 9 to write less? Is that okay? So on this one, the x squared cancels out. What's left over that we need to multiply times the b? X squared minus 9. Good. So on this one, the x minus 3 cancels out, but we still have the x squared and the x plus 3. Yeah, we'll distribute it in a minute. And then this one, the x plus 3 cancels out, so we're left with x squared and x minus 3 to multiply that one by, right? Okay, so now we're going to multiply everything out. So we multiplied the least common denominator. So this one canceled out entirely. We're just left with 2x plus 3 on the left side of our problem. Now, as I multiply these, I'm also going to distribute them, because I probably can't use the convenient x method on this one. Or at least I want to show you the other method, so I'm not going to. Okay, so a times x squared minus 9x. Is that okay if I just combine the whole thing and distribute the entire thing, or will that confuse you if I do it all in one step? Here, let me show you what it would be, and you tell me if I need to break it down a little further. Minus 9ax. That's it right there. So it would be a times x squared and a times x times negative 9. Just distributing everything through. So do you need me to go back to a previous step, or am I okay? Are we okay? Alright, so next I would have bx squared minus 9b, right? Maybe I do need to do the previous step. Are you getting lost? Okay, now I'm going to do cx squared distributed through x plus 3. So cx squared times x is cx cubed, and cx squared times 3 would be 3cx squared. And then last would be dx squared times x, so dx cubed, and then dx squared times negative 3, so negative 3 dx squared. So is that everything? Okay. Now, remember these things over here would eventually combine to equal this thing over there. So like terms have to equal like terms on this side. Okay? What types of terms do we have? We have x cubed terms, we have x squared terms, we have x terms, and we have constant terms, yes? So on this side of our problem, do we have any x cubed terms? So we just call it 0. Do we have any x squared terms over here? No, so we just call that 0. And then we have 2 x terms, and we have 3 constant. We have our constant term is a 3, correct? So now we're going to align stuff. This is weird, but watch what happens. So our x cubes, we're going to look at the x cubed terms. Okay, we're just looking at them. That's what that arrow is telling me, that I'm just going to look at them and then write them down. Okay, so the x cubed term on this side is 0. What x cubed terms do we have on this side over here? We have an a, but it's an x cubed. I'm not going to write that part down. I have a positive c with an x cubed. And I have a positive d with an x cubed. Okay? Now let's look at the x squared terms. What x squared term do we have on the left? What does it equal? 0. Okay? So now we look at our terms here that are x squareds. We have a b. Good. 3c, very important distinction, and a negative 3d. Okay, now we look at the x terms. What do the x terms add up to over here? 2. So over there, the x terms, negative 9a. Whoa, is that the only one? That's the only one, right? That's just a constant. So I think that's the only x term, right? So then the last one is the constant term, and that's a 3, and there's only one constant. So that's a negative 9b, correct? Okay, look what we've got. We have a system of 4 equations and 4 unknowns. If you wanted to, you could create a matrix of those systems and solve it using a method we've learned in this chapter. However, this particular problem kind of lends itself to substitution. So I would propose that we just use substitution rather than using a matrix. How do you feel about that? Okay. If, though, that you wanted to use a matrix, you would just need to make sure, like, see how you're missing b here? So it would be 1, in your matrix you'd have 1, 0, 1, 1, and then 0 would be what it's equal to, right? And this would be, a is missing, so 0, 1, 3, negative 3. In this one it would be negative 9, 0, 0, 0. In this one it would be 0, negative 9, 0, 0. Do you see what I'm saying by putting it into a system of matrices? Okay, but we're not going to do it that way. Okay, since these are pretty simple right here, we're just going to solve them. So how can I solve 2 equals negative 9a? What do I get? A equals negative 2/9, right? Okay, then let's do the same thing with this one. So solve 3 equals negative 9b. So b would equal 3 over negative 9, which is negative 1/3, right? So far, so good? You're quiet. I never know if I've lost you when you're quiet. Okay, so now we can take a and b and we can plug them in right here. So we can go, okay, so we're going to take these and plug them in. So we will have 0 equals negative 2/9 plus c plus d. And we will have 0 equals negative 1/3 plus 3c minus 3d. We still have another system of 2 equations, 2 unknowns, which we could now use a matrix method to solve if we wanted to. Do you want to use one of our matrix methods like determinants or inverses, anything? Or we could do something else that you learned last year. It doesn't matter. Okay, so let's solve the system. C plus d equals 2/9. Should I at least do that much? And 3c minus 3d equals 1/3. So I've moved the constants over to the other side, right? Okay, so now I have a system, 2 equations, 2 unknowns. How do you want to solve it? We could do substitution. We could solve the top one for c and plug it in the other one. Or we could do elimination. Do elimination? Okay, so if we want to solve, you guys are choosing to do elimination. Okay, hold that thought. Okay, so we could multiply this one by a 3, don't you think? Okay, so 3 times c, we would multiply that together and then add it. So 3c plus 3c is 6c. Then we'd have 3d plus negative 3d is 0. And then we'd have 6 over 9, which is actually 2/3. Right? Because it's 3 times 2 is 6, 9ths, 2/3. So 2/3 plus 1/3 is 1. So that gives us c is 1/6. I see all kinds of confused looks on your faces. Then you could just plug that in to here. Into our c plus d equals 2/9, right? So that would be 1/6 plus d equals 2/9. So d would equal 2/9 minus 1/6. We need a common denominator, 18. So d would equal 4/18 minus 3/18. So d equals 1/18. There we go. A, B, C, and D. Are we done? Nope, not till we do this. So, what is A? A is negative 2/9 over x. And then B is negative 1/3 over x squared. And then C is 1/6 over x minus 3. And then D is 1/18 over x plus 3. And just leave your answers like that. I know we don't usually leave fractions in fractions, but in this assignment you do. Yep. There's only 13 problems, and some of them are shorter and some of them are longer.